Two very long, straight, parallel wires carry steady currents I and minus I respectively. The distance between the wires is d. At a certain point of time, a point charge q is at a point equidistant from the two wires in the plane of the wires. Its instantaneous velocity v is perpendicular to this plane. The magnitude of the force due to the magnetic field acting on the charge at this instant is to be calculated. So let us say the plane of the screen is the same as the plane of the wires. So we have our two infinitely long wires here, which are at a distance d apart, carrying current capital I and minus capital I. Minus capital I just means that the direction is reversed. Now, according to the right hand thumb rule, the magnetic field produced by the wires can be figured out by making a thumbs up gesture with the right hand and aligning the thumb along with the direction of current. Then, the curl of the right hand fingers would give the direction of magnetic field, which in this case for the left wire is out of the plane on the left side and into the plane on the right side. And for the wire on the right, it is into the plane on the left side and out of the plane on the right side. Therefore, the net magnetic field in between the two wires would be into the plane of the screen. Now we have a point charge q at a point equidistant from the two wires, so it's somewhere along the center line, and its instantaneous velocity v is perpendicular to this plane. Therefore, the velocity is either completely out of this plane or into this plane. Then what is the force acting on it? The force is equal to the charge times the cross product of the velocity with the magnetic field, and this is a vector quantity. Now when we say cross product, it basically means QVB sine theta into n cap, where sine theta is the angle between the two vectors and n cap is a vector, a unit vector that is perpendicular to both vectors v and b. Now we know that theta is either 0 degrees or 180 degrees because velocity is perpendicular to the plane and so is the magnetic field. And therefore, sine theta is 0. Therefore, the net force acting on the charge is equal to 0.